savior when it comes to fuel servos. He is the guy, he and Joe are the guys that adjust my fuel servos when I get new engines from the factory and they're leaned out to the point where they barely run. And they will adjust them to get the fuel flow up to the point where they're totally legal, but they're to the high side of the fuel band. You've heard me say many a time, I want to see 1 inch at 100% power. I want to see 1 inch of manifold for every 1 inch of manifold pressure, 1 gallon an hour equality. 42 inches of manifold pressure, 42 gallons an hour on takeoff. You run the risk of anything less than that, you end up run the risk of burning up cylinders. And on every turbocharged engine out there, even the 601P with the 30 inches turbo normalized, they come out of the factory producing about 26 gallons an hour at 100% power, and that's enough to just cook cylinders. I don't know why Lycoming does that. Maybe Jim Christie knows what's going on, but I know that he's got a letter of authorization from the FAA to make the adjustments to the fuel servos for the Superstar program. So with that said, I'll introduce you to Kevin, and he's going to talk to you about fuel servos and fuel systems that they overhaul and repair. Kevin?
There we go. Good afternoon. My name is Kevin Feltz, and I'm with Mike's Aircraft Fuel Metering Service here in Tulsa. Little history about Mike's. It was started by Mike Burnett back in the late 70s. He opened up a fuel shop. It's progressed to the place we're at right now. He actually built that building in 1984. In 2007, he was ready to retire. I bought the business from him and have been there ever since. Have a couple of, it's just myself and Pete in the shop, and then Don in the office. If any of y'all talked with us before, you've probably talked to more than likely Pete. You know, I own the place. I do most of the Continental and carburetors. Pete has been doing Lycoming servos for 40 plus years. He knows them forwards, backwards, but unfortunately, he does not do public speaking, so you get me. But a little bit about what we do. We do general aviation, engine-driven fuel systems, and carburetors. Marvel Carbs, Stromberg carburetors, Lycoming, PCM, pressure carbs, anything and everything until you get into some of the oddball Simmons and Hollies and stuff like that. We don't get into, but just the everyday run of the mill, general aviation fuel systems, we do. Let's see. Like Ken said, for some reason, and I don't know if during Lycoming, test run on these engines, if something to do with tend to have a pretty lean condition. We get quite a few of them in, and what you have on these servos is typically during an overhaul, you have overhaul limits as far as your flow limits and settings and everything like that, and test points you have to meet. But they also have service limits, which actually give you a little more fuel on top of what the overhaul limits are. So we can actually verify that it will make overhaul limits. And once it's verified that overhaul limits are established, we can actually adjust them to the serviceable limits. If you've got something that's, like Ken said, if he's got a couple engines he's purchased, he'll pull them off, send them in. At that point, they're automatically in service since they've left the factory. So basically we can readjust them, get the higher fuel flow and make sure everything, at least goes a little bit better for, the cylinders and everything else. Ken's got let me grab this. He was nice enough to bring one of his RSA 10 ED1 Lycoming servos. Just a little bit about it. Many of y'all do your own maintenance or have mechanics or, okay. Just some of the basic things, your idle mixture adjustment is this little star wheel, back and forth. Occasionally you have to pull a pin and readjust a little bit if it gets full one way or the other. But typically, if y'all are trying to adjust your idle mixture and you turn that star wheel enough to bottom it out on one side, there's some sort of underlying problem, at that point. At that point, you at least need to contact us and say, hey, this is what I'm seeing, what could be going on. They're fairly, without getting into the engineering details and stuff like that are well above my head. The basic premise is you've got this bullet up inside which actually reads your air pressure that's coming into the servo through there. You've got a couple diaphragms in here. You've got an air diaphragm and a fuel diaphragm, and everything else is done by springs. And as that air adjusts in through there, those springs end up pushing back and forth on your fuel diaphragm to actually adjust your fuel flow. So your airflow dictates what's going on in there. All your adjustments as far as, fuel flow, stuff like that are up underneath this brass regulator plug. It is something you cannot adjust in the field. The only way to adjust it is on a test bench. So try not to do anything out there because it can cause all sorts of problems. For the most part, if you're operating these and you get them dialed in to where they need to be, they're pretty much will go full life of the engine and probably further. The most common issues you have with these are idle mixture issues, idle cutoff issues. Lycoming came out with a hard coat valve, a ceramic coated valve. Typically they come in with brass valves. There's good things and bad things about the brass versus the ceramic. Brass, nice thing is where unfortunately it does score a lot easier if, even a piece of hose material gets in there. You can actually pull the valve out, lap the valve, get it cleaned back up and go back together with it and everything's going to be good. You're out a couple hours labor. The ceramic valve where it takes a lot to actually score that ceramic valve, but if you do score that ceramic valve, it's basically pull the valve out, put it in the trash, buy a new one. Most of them run in the ballpark of anywhere between $200 and $300. The hard coat valve is a much better valve, but occasionally you do run across a couple of them that do get scored. Usually if you've got a hard coat valve that is scored, you've got an underlying problem somewhere else, or whether it be something coming apart, maybe in the fuel pump or something like that, you're getting actually something very hard up in there between that shoe and that valve.
Can we talk about the way fuel flows through that servo?
Okay.
Where it comes in, where it goes out.
Okay. Basically, you've got your inlet for fuel up on one end. You've actually got a gauge port. A lot of times this is just a plug. Only a few of them, aircraft applications will actually have a fitting coming off here.
Fuel pressure sensor.
But as your fuel comes in, there is a strainer filter up underneath or behind that fitting there. Comes down through You've got your idle valve, which is on the side where your actual throttle lever is, which, basically opens and closes an orifice in that valve to let the fuel go on basically through, your fuel diaphragm. Well, as your fuel diaphragm, can open to allow more fuel to come out, basically up underneath these plates, you've got a seat. And on the backside of this diaphragm, there's a ball. And so as the air pressure in here reduces or increases, it can actually fluctuate that to open or close that ball. And as that ball opens, it lets the fuel exit out your outlet here. And then on to, your flow divider. And then your flow divider is nothing but open and closed. That's all it does. If you've got a, number 3 cylinder is running warm or something like that, typically you've either got something in your nozzle, you've got something in the hard line between your flow divider, or something in, say, the fitting of the flow divider. Other than that, your flow divider really can't differentiate which cylinder it's going to without some sort of obstruction. Any other questions or?
Make sure they understand that there's no fuel flowing through the butterfly.
Oh, yeah, as far as,
Strictly air.
we get a few questions here and there that you might find fuel either around the butterfly or out on the outside of the throttle shaft, something like that. There is no fuel anywhere up around the throttle shaft, no fuel that runs through the throat of the carburetor, like what, say, a carburetor would be or anything like that. Typically, you run into something like that. A lot of times it's flow dividers aren't closing properly or something like that. And when you shut down, the fuel that's left up in the line between here and the flow divider can actually seep down into the cylinders, down through your induction, and get down into here. Occasionally, we'll pull this little brass regulator plug here. And if you ever pull that and it is just full of blue dye, occasionally it can be something, plates got an imperfection in it. There's possibly something leaking internal, but 85–90% of the time it's over priming. Flight schools especially, you're not going to see that with Aerostars, stuff like that. But if you run across stuff like that and it's full of blue dye, it needs to come off and go in for maintenance, because all it's going to do is gum everything up in there and cause you nothing but headaches, and you're going to be out somewhere and get stuck. But any other questions or? Yeah.
When you say that the fuel flow is strictly governed by the air pressure coming into the cone area of the system, isn't there some relationship between the throttle quadrant position and the spring tension on the diaphragm?
Well, as far as your throttle and stuff like that, by opening this up with your throttle, it's adjusting that airflow and that air pressure and everything going through. As far as on this, as far as the internal springs and everything else, it's all based on what is actually, the air pressure going into it to actually adjust, because it's actually spring tension between the two diaphragms themselves. You've got that ball that sits down there on a little seat, and then above that, there's another little seal that actually goes in there and keeps everything from, internally leaking and different things like that. But basically, there's, in essence, one spring in between those diaphragms, and that's actually one of the ways that we get them to actually calibrate, is they have different spring tensions that you actually go in and you actually adjust and can make your actual adjustments on that. Fuel pressure can make a slight change on it, but typically what these are going to see is it's going to have to be a drastic fuel pressure change to make some sort of, either a complete drop off or something very excessive, because this actually, very similar to like the pressure carb, that once it senses that pressure, it will actually adjust with the air as well to kind of combat that. Yeah, most of these are going to be in the 20 to 25 PSI range. If you're at 26, 27 PSI, you're never even going to see it on the servo. You might see an additional little spike up, but it's actually going to dial itself back down to it.
So if you had a controller that was overboosting for some reason, and it was giving you 42 inches manifold pressure at 3/4 throttle, this should compensate for that? It should still give you the fuel flow that you need, or because it's just going to see air pressure from the turbo?
Well, it's going to see that air pressure. That's getting a little beyond where, my knowledge on these.
On my Aerostar, I had some weird thing that happened every couple months that on takeoff, it would go from 42 down to 28 gallons per hour. And then it would, of course, be a detonation risk. So I pulled the throttle back, it would reset, and it would go back up to 42 when I passed the throttle.
Okay.
It was the hell trying to get it figured out. I sent the servo back twice. We did the controller swap, we did all kinds of stuff, and finally they stopped doing it. But I never did really figure out ultimately what it was. But I was just curious why they thought it was the controller, if in fact it's all based on air pressure. That's why I asked about the throttle.
As far as this is concerned, the throttle position, I mean, you're partially going to be blocking your idle orifice in there partially, as far as throttle's concerned, but, which would, I guess, change a little bit of your actual gallons per hour, but,
Not 10 gallons.
not to go from 42 to 28. No, that's fairly drastic. That's almost like something internally is hanging up, possibly. And that is one thing that the way the diaphragms actually stack in there with the plates, they use little small bushings and everything to help everything just flow smoothly. That can shift somewhat occasionally. And if it starts to hang up, it can start having issues similar to that. But I have left some of my business cards up here. Feel free to take one. Give us a call. Like I said, the guy that does my Lycoming stuff, I do some, but the guy that's been doing it 40 plus years, unfortunately, he is not a public speaker and was not, able to come today. But whether it be over the phone, and he can talk to you over the phone, or if you're local and walk in like Ken does, if he hasn't seen a problem that you've got, I would be surprised. I would be very surprised. I mean, he is. In fact, we get calls from some of the guys at Precision. Occasionally, if they see something that they've not seen, they'll call and talk to him, which, I mean, we do the same. If we run into something that's just completely something out of the ordinary, we've got our contacts up there. We'll call, hey, what have you seen about this? But, they know enough to call him as well. If he's, because every once in a while, we've learned to not say something's impossible, because we've seen some odd things, that you would, in theory, wouldn't think would be possible. But yes. No,
Actually, could you repeat that question just for online?
well, what he was asking is, if at 42 inches, well, I understood the question is you're burning about 35 gallons per hour aside. As far as from what I understand with Ken and stuff like that, we are component level as far as, we're not out on the aircraft. We're not, and these go on a wide range of various aircraft. But in what we've dealt with Ken and, a few other Aerostar owners and stuff, I would say I would be watching your EGTs and CHTs, because if they're pretty hot, but that does seem a little low from what I've, seen with the Aerostars.
Being that your solar heads are under control, do you think it's an accuracy in the flow?
It could be. It could be. That's the first thing I heard.
Flow meter?
So we pull back 45 by meeting. So
It's a Superstar 2. It's a TSIO 540 J2BD, and that little cheated motor.
Well, we just got to do it. It's still the same thing as the older. They're both the same. 35 per side on the takeoff. So,
Jim Christie, you got any input into that?
Well, you should be running about 0.7 brake specific fuel consumption, which is 0.7 pounds of fuel per hour per horsepower at full rich. And I was just trying to calculate what that is. It's like 210 pounds of fuel divided by 320 horsepower, if you're 42 versus 46, and that's 0.65. So you're a little leaner than 0.7. And for reference, 0.5 is that power. 0.7 is full rich. And like Ken said, some of the light Roman engines that we got years ago, the minimum fuel flow on the chart said 41.5 gallons an hour. And one of our customers had converted engines and he bought new ones. And he was used to seeing 43 gallons an hour full power. And he was seeing 38, 37 full power. His engines were running hot. So he called Lycom and talked to him about it. And then I got a call from the president of Lycom, along with engineers in his office, and he said, "Hey, why don't you try to get control of your customers?" Talking about this and that, I said, "Well, you guys have one of those little small red Lycom engine books that comes with the engine? It says minimum 41.5 gallons an hour." "No, we don't have one of those right here, right now. Let's see if you can get that customer control." So they don't really acknowledge, and their flow spec did not include a full power spec for fuel flow, because they were running naturally aspirated at 260 horsepower. So they didn't have a spec for 42, 45 inches. And Bill Leeds, who's an engineer that worked for Aerostar and is now a consultant for us, he worked for us for a long time, he wrote a new spec. And so we have that new spec in our Superstar installation instructions so that they can check full power fuel flow. So we're under power at 42 inches then? Well, you're a little leaner than 0.7, 0.65, which is maybe, maybe when you're 42 inches, the normal manifold pressure is 46. and more exhaust system back. So we ran that by Lycoming, the FAA, they all agreed we had to run 45, I think 46. Whenever more than that,
Two questions from the Yellowstar factory.
Oh, okay.
Pay more attention. Sometimes the secrets change, but
well,
I
it's
think
something
I
like
understand.
4 power takeoffs.
So regardless of the engine, Ken, 1-to-1 ratio, manifold pressure,
That's my rule of thumb. Watch those solar head temperatures on takeoff. Do what you can to keep them cool, below 40 degrees F.
Ken, use the microphone. CHD on takeoff. Yours. CHD on takeoff.
Yeah.
He's asking what it is.
Oh, like I said, I'm not looking at CHD when I'm driving here.
Yeah,
It's like,
but you got a co-pilot there, what's she looking at? You? Make sure your hair's straight. Yeah, there's nothing worse than the hair out of place when you're on takeoff.
makes sense.
Yeah, when you talk about solar head temperature, I don't like to see solar head temperatures above 400 degrees F. Now, Lycoming says you can run them all day long at 450 or better, and I don't own an engine shop to be building engines that often, but I like 400 degrees F to be a limit. If you see that, you can't do anything about it fuel-wise, you ought to be doing it with attitude, aircraft attitude. But every engine out there, every turbocharged engine, whether it's turbo normalized or boosted, I want to see 1-to-1. One needs some manifold pressure for every gallon an hour fuel flow, or vice versa. 42, and as Jim says, 0.7 is the real number. That's a little hard to compute for me, so I just say 1-to-1. Everybody seeing that number in their fuel flows? Their solar head temperatures are going to climb pretty quickly if you don't have that kind of fuel flow through these turbocharged engines.
Anything else?
Would you repeat what you said?
I
You're
just-
talking about manifold
I have 1 inch
pressure,
manifold.
42, right?
And 1 inch of manifold pressure is equal to the net 1 gallon per hour, so
Yeah.
that ratio, so, you know. it should be
Jim,
35
Is the Superstar 2 47 inches on takeoff?
Well, I think it's 45.
45.
Minus one inch. There's a chart in the flight manual supplement.
Okay.
It depends on the outside air temperature because it has a variable density controller on that.
Oh, okay.
If it's cold, it could be 44.
But at that 0.7 ratio, that's 403 horsepower.
Well, I'm sure it's about 380.
What I'm saying is that feels 1-to-1. Oh, sorry. Yeah, I mean, that feels a little high. Fuel flow.
I calculated 4.73 just now.
Fuel is still the cheapest thing you can put in these airplanes. Maintenance is the most expensive. Cylinders are not cheap, and they're hard to come by these days. Does that kind of answer your question, Roger?
Maybe.
Maybe.
We'll find when we get back and let go.
All right, good. Hey, Kevin, talk about the flow divider and how it works and what it does.
Okay. Flow divider's real simple. I mean, it's a body, fittings, cover, and then a diaphragm assembly. Your diaphragm, basically you have underneath the cover, a spring, diaphragm assembly with a stem plunger that runs up and down through the body. Your flow divider is nothing but open or closed. So basically, when you start your engine, when that fuel pressure builds up, depending on which flow divider you have, whether it's a 2 or 4 pound spring, when it hits that PSI, it cracks that flow divider open, lets fuel run to your cylinders and things,
How does it
Start
know
up.
which cylinder to send the fuel to?
Whichever comes first, basically, just path of least resistance. So, you will get, occasionally somebody, will get a call, one engine or one cylinder's running hot, one engine's running real cold, something like, or excuse me, cylinder. Um, Being hot is pretty easy, because it usually means something's plugged up in that individual nozzle line or possibly in the flow divider.
Fuel injector nozzle.
Yeah, in that fuel injector nozzle. A cold cylinder could be somebody, we've seen injector nozzles that have come in and somebody out in the field has taken a piece of safety wire and jammed it down through there trying to clean it out. And like Omen nozzles, it's a little harder to do, especially if you have the newer nozzles with the little steel insert. You pretty much have to use a pretty strong drill to open it up, but you can slightly open those up to where it flows a little too much. But other than that, it's usually something other than the fuel system. Yes.
So if you have a classic hot cylinder on one side, you can move the one nozzle to a different cylinder, see if the symptoms follow.
That's the easiest thing to do is first thing, a couple things you can do, and that's usually the easiest. Swap it side to side is one of the easiest because
The second half of my query is the flow divider, when it's closed, classic hot start scenario. All we're dealing with is the fuel that's left over in the injector line between the flow divider and the cylinder. That's what's dribbling down in there causing the problem, right?
in essence, because when that flow divider shuts off, it's gonna drain what's in that that line and that nozzle is gonna go down into your cylinders. And can
It's also hot and the fuel is atomized. So it's not gonna have much fuel quantity to it. That's why it's dripping down into the cylinder and the Lycoming procedure for starting that engine is to take the throttle, push it full forward, keep the mixture to idle cut off, and crank the engine until it fires. And then bring the mixture in slowly and reduce the throttle.
So you have a momentary time slot there where the cylinder's been kind of washed with fuel. And it's a little short lubrication. If you're following the correct procedure, that's all you can do.
That's right.
All right.
just
The diaphragm and the flow divider is always different. What other symptoms do you have?
well. Okay, he asked about on a Lycoming flow divider, if after time they get kind of old, hard, and stiff. Lycoming flow dividers, precision flow dividers, usually you don't see that. That is very common in a TCM engine, TCM flow divider. TCM uses a black material for their diaphragms that does not age well, and inactivity accelerates that aging process, and they do get hard, they get stiff, and it makes it very hard to start your engine or actually keep it running at idle without turning your electric boost pump on. The fluorosilicone type diaphragm that Precision uses for their servos and their flow dividers, that orange material, we've seen them after 20 years that still just as soft and pliable as they were, the day they were new. So you don't run into that as much with the Lycoming. That's very, very common. We deal with those literally on a weekly basis, and it doesn't affect the fuel pump too much as far as the diaphragm getting stiff, but the flow dividers, it's a very, very common issue with TCM engines.
That's exactly what we see. I had
Yep. Yeah, it's probably the most common problem you see with the TCM engine, especially one that is either set a lot or doesn't get flown much, or somebody's purchased and I'm gonna get it up and running, and it's a very, very common issue.
I got a question for the audience. You take off and you notice that cylinder 1, 3, and 5 is getting extremely hot. But 2, 4, and 6 is just fine. What's going on? What? No. Come on, guys. George.
Up the deck on one side.
I'm sorry.
Up the deck leak on one side.
Upper deck leak.
That's exactly right. Deck reference airline. In fact, I got Danny, you here? Danny, come on. I got a text message for him from he was leaving Atlanta. They had to turn around and go back, and just a simple response. He says, I got it, you're right, here we go. We're off again. But yeah, simple things. Think it through and, pick up the phone and text me or text Jim or send anybody a message that's Aerostar knowledgeable or Lycoming knowledgeable. They can tell you pretty quickly whether you got a real problem or whether you got something you can do something about rather quickly.
So how do you fix it? What do you do?
Tight, it was a fitting loose. It was the supply line, the hose to the back of the engine that went from hose to deck reference air line, the heart aluminum line.
He said yesterday at the dinner, was the one you gotta pull off, pull the oil filter off. That was the.
Oh, he took it loose at the airbox. Okay. Yeah, that's where it was. Okay. Good. Well, we got here safely and sound. Anybody else have any questions for Kevin?
Yes.
Sir.
I just, for the confusion, wanted to retract my comment. I had the typo, and I agree, 43, 44 gallons.
Fuel is your friend, guys, in these turbocharged high horsepower motors. Fuel is your friend. Anything else you'd like to share with us, Kevin?
Nope, guys, like I said, my business card's up here. It has the shop number and everything on it. Feel free anytime you've got questions. Myself or Pete, be glad to help you out any way we can. Mm-hmm.
You said something, you say, you think something's going on, you can go through and say, oh, yeah, I found an issue.
Yeah.
You do that?
Yes, we do IRANs. Now, you send me something that's been 15, 18 years old. It depends on the condition.
I understand you making an overhaul, but there's still a lot of problems before you do it.
But yes, if you've got an issue or something like that, and say you want to send it in to have it inspected and repaired, we can do that. Or, hey, I've got this issue, I'm sending in for overhaul. Can you test it and then let us know what you find, or give us a tear down report of what you see, as it comes apart. And yeah, we'll be glad to do that.
Typically what I do is to take a fuel servo over to them and tell them, hey, the pilot's complaining at 30 inches of manifold pressure, he's only flowing 26 gallons an hour. That's all that Pete needs to know, and he's off and running. He'll put it on the bench and test it first, and if it needs to be overhauled, it gets overhauled. If it needs adjustment, it'll be adjusted.
I've seen issues where you just send something in, they just want to overhaul, and they tell you what's wrong.
Yeah, we're not like that. I know quite a few of the shops that do that, and we're very customer friendly. As far as we spend a lot of time on the phone talking with customers, stuff like that. Not just send me your stuff and we'll call you when it's done. Yes.
One more issue, fast question. 32 and a half inches for burning. Are we still?
That's not 100% power. We're only interested in 100% power.
I just wonder if we're not burning
Your cylinder head temperatures are your indication of your engine tank.
We always deal with that.
Okay,
23 gallons an hour, 32 and a half.
and you've got a POH, so whatever the tables and the POH tell you, that's what you should be doing. I'm talking about 100% power when I talk about 1-to-1.
Yes.
Go ahead.
On your, potentially, your test and test. So the way it works is you put in 42 inches of manifold, and then
Well, no, things are set up a little different as far as the way the flow bench works with,
Inches of mercury.
yeah, we run off inches of mercury, inches of water, to actually do the settings. It's, basically calibrated through, precision and everything else,
Pounds per gallon of fuel.
Yeah.
Pounds per-
Yeah.
pounds per hour.
Everything we deal with is pounds per hour.
so the units are different. Basically, you can adjust, the way it works is you adjust the input on the manifold pressure, and then you can adjust the flow from that.
Yeah, basically, if you come in and you're wanting 42 gallons at 42 inches and you're only getting, say, 38, we can go in there and actually, see where, first of all, we got to find out where you're at, make sure you don't have some other issue causing it to be like that. Then at that point, we can actually increase at the top end settings, actually increase your fuel, at that point up to where the max service limits are. And that usually is what takes care of everything.
Anybody else? Kevin, thank you so much for coming.
Yeah, one more.
Oh, more?
Fuel
David?
injector nozzles, what do you recommend to clean those with?
He asked what we use to clean fuel injector nozzles. I know a lot of people in the field use Hoppies. Hops number 9. We actually use a ultrasonic cleaner that basically like a jeweler's, actually from a clock shop that we use that cleans them pretty well. But as far as out in the field, stuff like that, Hoppy's number 9 is pretty much standard.
What do you use to do with an ultrasonic cleaner for fluid?
It's a watch maker's, it's by, I want to say it's like by a company called LR, and I can see it in my head, but, and it's like, solvent number 142 or something like that. I don't know.
I use Hopkins number 9 in the ultrasonic cleaner, maybe I should try a different product.
Well, no, Hoppy's works just fine, clean them, but, we get a little bit better finish on them, when we're doing the overhauls and stuff with this. But, and if you're interested, get one of my cards and just give me a call and I can actually, look at it and tell you exactly what it is. But it is, the stuff we use runs about $64 a gallon. So it's a little more expensive, but it does a better job because we're also cleaning multiple, fuel system components over and over, and we get, that lasts a lot longer for us than what, the Hoppies does.
I've got 2 Lycoming engines on order right now for Joel Champlin's airplane. And the fuel servos will come in a box glued to the pallet. I'll pull them out of the box, take both of them over to Pete, and they will not only enrichen them to where they'll flow the 30 gallons an hour on takeoff, that they'll also match them. That's the other advantage of having Mike's fuel metering work on them. If you want to have your match, so your fuel flow is matched, and you've got decent engines without other kinds of problems, these guys can do it. Just send them the 2 fuel servos, and they'll match them for you.
Oh, and on that, the carbureted engines from Lycoming now come with Avstar carburetors, or the fuel injected coming with Avstar servos now? Do you know if that's?
Yep.
Okay. We do have all the certification manuals, everything. and can do the Avstar just like the Precision. So Avstar, Precision, whichever one you've got, we can take care of.
Okay, thanks again.
Well, thank you all very much.
Does anybody want to take a quick break before we start our maintenance panel? Take a quick break.
You want a prize, and you weren't here to get it, so it's mine.
My servers.
Say what?
If you want a prize,
Like Shannon, you got nice, yes.
do you?